Lesson 8 is graphing lines, and 8.1 starts us off with graphing lines from ordered pairs on a table. So the most important thing that we're going to pull out of 8.1 is more so how to set up our graphs, like how to label the X and Y axis, how to scale our graph, and just make sure that we're able to get all of our points from our table. So example 1, Anthony wants to know if studying for his math test helps him improve his test scores. He made a table that lists the time spent studying for a test in minutes and the score he received on the test by percentage. Graph a line to represent the data from the table. So down here where it says tips for setting up your graph. So the first one says the independent variable goes on the x-axis. So when you have a table, most of the time the independent variable is on the left side and then the dependent variable is on the right side. But you just always want to double check. So remember that the dependent variable y relies on the independent variable. So in this case, like our score or Anthony's score on his exam depends on how much time he spends studying. So our independent variable is going to be the time in minutes, and then our dependent variable is going to be the score as a percentage on his test, and that means that time is our x, score is our y. And this covers the first two bullet points. So independent variable, which is x, goes on the x-axis, and then dependent variable goes on the y-axis. We're going to go ahead and label that now. So on our x-axis is time in minutes. And that represents how much time he's spending studying. And then on our y-axis, it represents his score as a percent. And then for the third bullet point, you can determine the scale based on the table. So we don't want to just go ahead and like start scaling this without looking at the values on the table, because like, for example, if I just said, okay, this is 1, 2, 3, 4, and so on, I'm probably not going to make it all the way up to 60. And that's like at least what I need to go up to get all my points on. I actually need to go higher to try to get like an extension on my line. So I don't want to scale it by ones, but it looks like if I scale this graph by fives, I should have plenty of space. I'm going to go ahead and scale it by fives, at least on the x-axis. So this will be 5, 10, and then I'm going to like kind of skip every other one, so I won't write 15, but that'll be 15, and then 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100, 105, 110, 115, 120. I'm going to stop there and just continue with my marks because you guys can see. And just remember, when you scale your graph, each tick mark should be the same value. So like I decided the spacing is by 5. They all need to be by 5. And then for the percent, keep in mind, like if our y-axis is like the score in percent, there's a maximum we can go up to because you can't really get like over 100% on an exam. So we can count how far up this goes, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So if I scale it by 5, 5 times 14 is only going to give me 70. And I don't really want my like highest possible score to be 70. I want to get up to 100. So I'm going to scale my y-axis by 10. So the x and the y-axis don't have to be scaled the same exact way. It's just like the individual tick marks on each axis need to be the same. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And then from there, we can go ahead and like start plotting our points. So remember that like a table is just an arrangement of points. So what that means is like this is the point 20, 72. So think of it, and you can even rewrite it with parentheses. So 20, 72. So we go to 20 on the x-axis, which is right here. And then we would go up to 72 on the y-axis, but like our y-axis is scaled by 10, so there's not an exact mark for 72. So we would just have to estimate it. So I'm going to estimate it right here. So it's at 20 on the x and then a little bit above 70 on the y. And then the next point is 30, 74. So we'll go from 30 on the x-axis up to about 74 on the y. So just like a little bit higher this time. And usually like the kind of farther apart your scaling is, like ours was scaled by tens, it's kind of hard to get those exact little numbers. You just have to do your best. And then the next one is 45 and 70. So we'll go to 45 on the x-axis and then, oh wait, sorry, 77. And then up to about 77 on the y-axis. So looks like about right here is where they're gonna meet. I know those are super close together. But 45 and then up to about 77, which remember the y-axis is scaled by 10, so this is technically 80 right here, so it needs to be a little bit below that line. And then the last one was 60, 80. That's nice. That'll be a nice clean point. So 60 on the x-axis and then 80, and then 80 on the y-axis would land us right here. And then from there, we just need to connect our points. So you'll use like a straight edge or a ruler and just draw a line throughout all your points. Hopefully they land up on the same line like mine. You may find that like later on you need to kind of adjust your points a little bit, but especially when our scaling is kind of a little bit spread apart, it can be hard to get our exact points. So extend your line, use a ruler, make sure it's straight, and then now we have a line that kind of represents how much his study time impacts his overall score. And we could even use this line to estimate like how long he would have to study to get a certain grade on his exam. So like let's say I wanted to check to see how long before he gets a 90, I would go to where it intersects with 90 on the y-axis and see how much time that was. So that was about 95 minutes. And again, it's an estimate, but that's a good estimate for us to judge. Okay, moving down to 8.2, which is graphing from slope-intercept and point-slope form. So first we're going to graph from slope-intercept form, which that is y equals mx plus b. And I'm going to show you two options. One is with a table by like finding a table of values and getting points, and then the other option is kind of like a shortcut. Okay, so example one is y equals 2x minus 4. This is called a linear equation, which is like when you graph it, it'll be a line. So whenever you're graphing a linear equation, you can always make a table of values, and you could just do like -2 up to +2 for x. And it always works, but it's not always the most efficient way to go about things. So the way that making a table of values works is you would take your x value and you would substitute it into the equation and then solve for y. So if we did that, it would be y equals 2 times, instead of x, I'm going to substitute this -2 in here, minus 4, and then you would simplify it. So I'm going to zoom way in here because I don't have a ton of space, but I would have to multiply 2 times -2, that's -4, and then I would bring down the -4, and then -4 minus 4 is -8. So for that point, it would be -2, -8. And then you would just repeat that process all the way down your table so you can kind of see it takes a little bit of time. So I'm going to keep working down the table. Next, x is going to be -1, so it'd be y equals 2, and then instead of times x like we have in the equation itself, we would put a -1 there, -4, and then I would do 2 times -1, which is -2, -4, and then -2 minus 4 is -6. And then next I would plug in 0 for x, so it'd be y equals 2 times 0 minus 4. And then 2 times 0 is 0, minus 4 equals -4. And then next I would plug in x equals 1, which just kind of keep in mind if we look back at our equation up here, all I'm doing is I'm putting like each of these x values in where the x is from the equation. So every step is the same, I'm just switching out a different x value. So next x would be equal to 1, so it'd be y equals 2 times 1 in the parentheses minus 4. And then 2 times 1 is 2, minus 4 is -2, from 2 minus 4. And then the last one, I just need to plug in x equals 2. So it's y equals 2 times 2 in the parentheses minus 4. So 2 times 2 is 4, minus 4 is 0. So then now I have a bunch of points. I'm just going to list them. I'm not going to graph them yet, and I'll kind of explain why after. But each of these x value, or each of these y values go with the x value that we plugged in to find them. So this is -2, -8. And then -1, -6, and then 0, -4, and then 1, -2, and then 2, 0. Okay, so I'm going to leave those points for now, and then we'll worry about them after. I'm going to go ahead and show you option 2, which is more of like the shortcut. So these steps, if you are not familiar with them, I would write them. When I say these steps, I mean like the steps 1, 2, and 3 for option 2. I would like write them on a little note card or like a sticky note, like somewhere you can kind of like keep them for easy access. So step 1 says put a point at 0b. And when it refers to b, it's asking you to compare your equation to the y equals mx plus b formula. So if I compare that, the number that's in the spot of b is a -4. So that means that b is -4, because that's where b is in the actual equation. So I would put a point at 0, -4. So if it's 0, -4, I don't go left or right on the x-axis, I just go down to -4 on the y, and I put a point there. And then for step 2, it says from 0b, which is that point that we just put on the graph, use m equals rise over run to find your second point. So rise over run is like kind of like a formula that we use for slope when we're graphing. So if we look at our equation, m is 2, because that's in the spot where m is. It's m times x, and in our equation we have 2 times x. So I could say, okay, m is 2. But if you look at this rise over run, it's a fraction. So I want to think of my slope as a fraction, or my m as a fraction, which would make it 2 over 1. So 2 is my rise, and that means that's how far we're going up or down. And then 1 is my run, which means how far we're going left or right. So since they're both positive, to get from my 0, -4 to my second point, I'm going to rise 2, so I would go up 1, 2 in the positive direction, and then I would run 1 in the positive direction, so I would go right 1, and then I would get my second point. And then because these are linear equations, you only need 2 points technically, because they're straight lines, so any other point is going to fall on that same line. So one more time, just to kind of quickly go through how we got our second point. Our slope was 2, m was 2, so that means the rise is 2, So we go up 2, and then our run was 1, so we go right 1. And then 2 points is enough, so that brings us to step 3. It says use a straight edge to draw a line connecting your points. So you would use a ruler to draw a straight line through your points. And then the reason I didn't graph the points initially from option 1 is I wanted to show you that now that we have kind of our shortcut line, to show you that it does contain all the points that we found from the table. So if I go back and try to graph all my points from the table, they should fall in this line. So -2, -8, I would go left 2 and then down 8, which is right here. -1, -6, I would go left 1 and then down 6, which is right there. 0, -4, I don't go left or right, I just go down 4, I have that point. 1, -2, so I would go right 1 and then down 2, I already have that point. And then 2, 0, I would just go right 2, and then I wouldn't go up or down at all, so all the points from our table ended up being in our line. So it just shows you you can do either option, just one definitely takes a little bit longer, but they both get you the correct answer. Okay, example 2, graph y equals 2/3 x plus 3 using option 2. So this time just the shortcut. So I'm going to rewrite y equals mx plus b above. And then let's just identify what m and b are just to make our life a little bit easier. So m is the number that's in front of x. So m would be 2/3. And that's just our slope or our rate of change. And then b, b is what's called the constant. That's a number without a variable. So in this equation, b would be 3. So for step 1, it says put a point at 0b. So if b is 3, that means I have to put a point at 0, 3. Just whatever b is from the equation goes in there, and that gives you your first point. So 0, 3 is we don't go left or right at all, we just go up 3, so right there. And then notice that it's always we're putting a point at 0b, so anytime the x coordinate is 0, our first point is always going on the y-axis, and it's actually called a y-intercept. So another way that you can approach this is just whatever b is, so in this case b is 3, you can put a point at 3 on the y-axis. So that b point will always be on the y-axis no matter what. And then step 2 says from 0b, use m equals rise over run to find your second point. So our slope was 2/3. So we think of slope as rise over run. So since they're both positive, we'll go up and to the right. So we'll start at our 0, 3 point and we'll go up 2. So we want 2 up and then we'll go 3 to the right to get our next point, which should be at 3, 5 right here. And we just need 2 points. We can go down to step 3. We can use a straight edge to connect our points. One thing I want to mention before we move on to example 3 is so when you're dealing with slope, so in this case, our slope was 2/3, so we went we rose 2, we went 3 to the right because it was positive. You can also switch the direction. So if you're ever at a point where you're kind of gonna fall off the graph if you go in that direction, we can switch both of these. So technically we could have gone, just kind of as a side note, we could have gone 2 down and 3 left, if we switched both directions. So instead of 2 up, 3 right, we could have gone 2 down, 3 left. As long as you switch both directions, you'll end up on the same line. So notice if I go 2 down and then 3 left, I end up at a point that's also on the graph. So just kind of keep that like in your memory for if you're ever like say at a point that's like really close to the edge of the graph, you can go in the opposite direction to get your other point if the kind of normal direction is going to be off the graph. Okay, so example 3 is point slope form. So here's our formula for point slope form. So y minus y1 equals m times x minus x1. So the steps are a little bit different, so maybe grab like another sticky note, another little note card to keep track of these steps. So step 1 says find and graph x1 and y1. So if I just kind of compare the formulas, like y1 is right here, it's the part that's being subtracted from y. And then x1 is right here. It's the part that's being subtracted from x in the formula, but we have to be careful with those negatives. So since this negative is already here, that means that y1 is actually just positive 5. So we can say y1 equals 5, but notice there's also a negative right here. So x minus x1, the like x1 that changes that minus into a plus, it actually means that x1 would be negative. It would be negative 3. Because in order to get that like x minus x1 to turn into this plus right here, it's because this is actually x minus negative 3. And if I do x minus negative 3, that double negative turns into the plus we have down here. Okay, so just be really careful. Usually whenever you see like negatives in formulas like we have here and here, it means that your numbers are actually the opposite of what they may look like. So this was a minus 5, y1 was positive 5. This was a plus 3, x1 was negative 3. Okay, so we have x1 and y1, so we can put them together as a point. x1 goes first, so negative 3, and then 5, and we're supposed to graph that. So negative 3 would be left 3, and then up 5, so up here. It's kind of off, sorry. Negative 3 up 5, or left 3 up 5. And then step 2 says from x1, y1, use m equals rise over run to find your second point. So we have to find m. M is right here in front of the parentheses in that formula. So if we match that up with our equation, our m is negative 2. So we can say m equals negative 2. And then we think of slope as rise over run, like a fraction. So I'm going to say this is over 1. And then if m is negative 2, that means for our rise, we're going to go down 1. And then our run, we're still going to go to the right though. We can only make one of those go in the positive direction. So like we'll make 2 go in the negative direction. We'll make that down. And then we'll make 1 go in the positive direction. We'll make that go to the right. Because if I were to make this, say I did, don't write this because it's incorrect. So if I did negative 2 over 1, and I went down 2 for the negative 2, and then I went left 1 because it's negative, I would have to make this a negative 1, and then negative 2 divided by negative 1 is actually a positive 2. So that would give us a positive slope technically. So we don't want to do that. Whenever you have a negative slope, only one of these should go in the negative direction. So usually down and to the right is the easiest way. So we'll start from our negative 3, 5. So from there, we'll go down 2, and then we'll go right 1, and then put a point at negative 2, 3. And then we just need 2 points. We can go ahead and move down to step 3, connect them, and then we'll have our line. And then one more thing to kind of add on that like negative slope point is, so if this is negative 2 over 1, let's say I wanted, like if I was out of room on my graph, I had to go in the opposite direction. I could go 2 up. If I were to go 2 up to make it a negative slope, I would just have to go left 1. So kind of goes back to like switching both. And then if you kind of check on your graph, if you go 2 up and the left 1, you also end up with a point on your graph. So you just have to be careful. Also, kind of one helpful thing when you're checking your answers when you're graphing is that when you look at a graph, like when you read a graph, I'm like doing air quotes right now, but a positive slope should be going up and to the right. Like that's going up and to the right. That's a positive slope. And then a negative slope should be going down and to the right. So we always read graphs like you read a book, like as like left to right. So positive slope is going up and to the right, and negative slope is going down and to the right. And then that matches up with what we had from our equations. Like this had a positive slope, the graph was going up and right. This had a negative slope, the graph was going down and right. But it's always to the right is the direction that we're looking because that's how we read. Okay, so 8.3 is graphing from standard form. So there's a couple different ways that you could approach it. One is by finding the intercepts, and one is by just changing it to slope-intercept form, which is y equals mx plus b. So we're going to go through the intercepts way first, and then just kind of see how it matches up with our slope-intercept form. So example 1, this is the only one from 8.3. Graph 5x plus 4y equals 20 by finding the intercepts. So if you have an intercept, you don't need to draw this on your graph yet, but like let's say I have a point at, oops, I'm going to start with x. Let's say I have a point at 2, 0. That would be, if I had a line that crossed there, that would be an x-intercept because it's a point on the x-axis. But more importantly, the reason it's on the x-axis is because it has a y-intercept of 0. Or sorry, a y-coordinate, excuse me, a y-coordinate of 0. So if we wanted to find the x-intercept, we have to substitute in or plug in y equals 0. Because any point on the x-axis, any x-intercept, is always going to have a y coordinate of 0, y value of 0. That's what makes it fall on the on the x-axis, excuse me. So we just have to plug in y equals 0 into the equation that we're given. So we'll put that 0 right here for y, so it'll be 5x plus 4 times 0 equals 20. And then now we solve that equation for x. So do 5x, and then 4 times 0 is just 0. So that part goes away, equals 20. And then my goal is to get x by itself, so I can divide both sides by 5 to cancel out the 5 that is being multiplied. 5 divided by 5 cancels out, and then I'm left with x equals 20 divided by 5, so 4. So we plugged in y equals 0, we got x equals 4. So that means that we have a point where the x coordinate is 4 and the y coordinate is 0. Because we put 0 in for y and we got x equals 4. And then to find the y-intercept, we just do exactly the opposite. So we plug in x equals 0. Because any point that's on the y-axis, so like this is 0, 3, this is 0, 7, they all have x coordinates of 0. So in order to be a y-intercept, they must have an x coordinate of 0. So we're going to take this same equation and we're going to put that 0 in for x now. So it'd be 5 times 0 plus 4y equals 20. And then 5 times 0, that's just 0, so that goes away. So we have 4y equals 20. And then our goal is to get that y by itself. So I have to undo the times 4, so I have to divide both sides by 4. And then 4 divided by 4, that cancels out, and I'm left with just y equals 20 divided by 4, so 5. And then from that, I have a point where the x coordinate is 0, because I put in x equals 0 to get it, and then the y coordinate is 5, because I got out y equals 5. So I can put these 2 points on my graph. So 4, 0. Right here, I go right 4, and then I don't go up or down at all. And then 0, 5, I don't go left or right, I just go up 5, so up here. And then you only need 2 points because it's linear, and we just need to use a straight edge to connect those lines. Okay, so that's one method to graph when it's in standard form. I forgot to write the formula for standard form, but that is ax plus by equals c. So whenever it looks like this is one method. The other way is to change it into slope-intercept form, which that's like our y equals mx plus b. So that's what we'll do down here. So change 5x plus 4y equals 20 into slope-intercept form. So notice with slope-intercept form, y is by itself. So that's what we want to do. We want to get y completely by itself. So the first thing I can do is I can undo the thing that is being added to it. So I can get rid of that 5x. So I'm going to subtract 5x over. And then 5x minus 5x, that cancels out. I would bring down the 4y. And then notice with slope-intercept form, the x part goes first. So I'm actually going to put the minus 5x first. And then the constant, the number that doesn't have the variable, goes second. So I'm going to follow it up with plus 20. And then keep in mind, like, this was a minus 5x, so that negative stayed with the 5x. This was a positive 20, so this stayed plus 20. And then if the ultimate goal is to get y completely by itself, I have a 4 that is being multiplied by the y. So I'm going to have to divide both sides by 4. And I have to divide everything in the equation by 4. So the 5, or the negative 5, and the 20. So 4 divided by 4, that cancels out, and it gives me just y, which is what I'm going for. And then negative 5/4, we're just going to leave that as a fraction. It's not divisible by 4, so it's best just to leave it as a fraction, especially when we're dealing with graphing, because we always view slope as a fraction. So negative 5/4 times x, and then this is 20 divided by 4, so plus 5. And then now we changed it into slope-intercept form. I just want us to go ahead and compare that equation to the graph that we already had. So this is my m, my slope, and then this is my b, my y-intercept. So remember, b is like where we start. It's the point that we start on the y-axis. So right here, we have a point at 0b, which is 0, 5. And then the slope m is negative 5/4, so that would be telling me I have to go down 5 and then right 4. So let's just check it. If I go down 5 and then right 4, I end up at my exact other point. So just another way of getting the same exact answer. Ultimately, like, you can completely decide which way you prefer to use.